Welcome to the demo video of our scrollytelling website. Can you see the bias? A comparative study of MLPs versus KANs on human-centric data. Imagine a world where you apply for a job, a loan, or a college admission. An invisible algorithm may decide your fate. However, this unseen force isn't always fair. Consider the widely studied adult datasets. The goal is to predict whether a person's income would surpass $50,000. The problem is this dataset carries historical imbalances. As we can see from the graph, females are less likely to earn more than $50,000 compared to men. We trained a logistic regression classification model and used a confusion matrix to showcase the actual accuracy on male and female. We noticed that the model tends to predict more accurately for males earning more than $50,000, 30.2% versus 25.3%. In this study, we decided to explore whether some of the most recent advances in deep learning could help mitigate this algorithmic bias problem. To do that, we decided to use the WESAD dataset that focuses on wearable sensor data. Using this data exploration tool, we realized the gender distribution is biased. There are only 3 female participants. Also, the handedness is imbalanced. Diving deeper, these are the features that we will use to train our deep learning model. The machine learning model will use electrothermal activity, EDA, blood volume pulse, BVP, and body temperature, temp, to determine the stress level of individuals. To model this dataset, we decided to use neural networks. Neural networks are machine learning models that can fit to an arbitrary function. Intuitively speaking, the more complex the model is, the more expressive and more capable the model becomes. Although at the cost of being more computationally expensive. The multilayer perceptron, or MLP, is the classic type of neural network made by layered digital neurons. It is the fundamental building block of deep learning. However, MLPs are known to manifest biased outcomes if the dataset is biased. On the contrary, the recently proposed Kolmogorov-Arnold network might offer a solution. Instead of having linear weights between nodes, KANs have curvy univariate functions, also called splines. This may improve generalization. And in theory, while MLPs are faster and more versatile, KANs have improved generalization. That is, it works better when fewer data is presented. This can potentially help the underrepresented groups in datasets. We trained a classification model for each one of the participants, using the aforementioned features and models to predict their anxiety levels. It turns out KANs indeed offered better fairness for our unbalanced dataset. In fact, the accuracy for female is slightly higher than male ones on KAN. While MLP is biased towards male participants. That being said, we observed reduced overall accuracy for KANs when compared with MLP. Therefore, the main takeaway is twofold. First, while in theory, MLPs and KANs should offer similar accuracy, in practice, there is a trade-off. MLPs are more accurate than KANs, but KANs are less biased than MLPs. Moving forward, we might need novel architectures such as the transformers. Better data research that can enrich our datasets might also help. Thank you for joining us on this tour.